Hey guys, welcome back. So today we're going to review the unit circle. We all know it's one of those things that you really could just memorize. And that's fine if you're good at memorizing things. So this lesson is kind of optional. I like to show why the unit circle is what it is. And it's my favorite lesson to do in calculus because you've already spent pre-calc using this. But usually when you learn it the first time around, it's just so overwhelming and you resist learning it, and then you realize you've got to use it a million times for the whole year. And then when I show where it came from the second time in calculus, it's like, whoa, I had no idea where that came from. So that's what I'm going to do right now. I'm going to show you why the unit circle is what it is, and I'm also going to show you some tricks for trying to memorize the radian values. You know, the radians, little fractions. So you guys probably remember just sort of memorizing these numbers. Okay, and if that works for you, then that's fine, because yeah, there's a pattern, 6, 4, 3, and 2. You know, you can do it that way. But I'm going to show you that what my ultimate goal, we will use trig all year, but it's not with every problem. So I would like you to just memorize quadrant 1 and be able to apply that to the rest. So that's the goal of this lesson today. Again, it's optional. If you just want to memorize it, fine, but please, please, please do not require always having the entire unit circle being drawn or having to look at it, because you're just not going to have time for that. Okay, so let's get started. The unit circle is actually based on some stuff that you learned way back when in geometry about 30, 60, 90 triangles. Okay, so only for 30, 60, 90 triangles, if this was a right angle, you may not remember, but you once learned that if this is 30 degrees, the side across from that is the shortest side. And if we call that x, the hypotenuse is always twice that, or 2x. We go back to the short side. The longer leg, this one, is the short side times root 3. Okay? So you may not remember that, but this is a 30, 60, 90 triangle. Okay? An example, if I told you this was a 30, 60, 90, then if this were 2, the hypotenuse would be twice that. Go back to the short side. If this is 2, the longer leg would be 2 root 3. Okay? I didn't really prove it to you or anything like that, but you could do the Pythagorean theorem to at least justify it to yourself. A squared plus b squared equals c squared. So 4 plus, this would be 4 times 3, so that'd be 12, equals 16, and you can see it does check at least. All right, so now let's just do a couple real quick problems. Now you don't have to be taking notes or anything. This is just a sit back and enjoy the show kind of a lesson, okay? Because you know at the end result is just the unit circle. So don't feel like you have to hurry through taking notes right now. All right, so doing a couple quick examples just to make sure that that clicked. Okay, so if the short side is 5, the hypotenuse would be twice that. Go back to the short side. The longer leg is the short side times root 3. Okay, if the short side is 8, hypotenuse is 16, short side is 8, longer leg is 8 root 3. Working it a little bit backwards, if the hypotenuse is 14, the short side would be 7. If the short side is 7, the longer leg is 7 root 3. Okay, well, what does that have to do with my unit circle? Well, you already remember, I'm sure, there's a lot of 30 and 60 degree angles on that unit circle. Okay, so first of all, why is this called a unit circle? That's important. Well, it's called a unit circle because it has a radius of 1. So this length right here is 1 unit, okay? And that's true of all the radii you could draw inside there. All right, we're going to go to our 30 degree angle. That's a 30 degree angle, approximately, since I made those little dots there, and who knows if it's perfect. And I'm going to drop a vertical. If that went straight up and down, then this would now be a 30, 60, 90 triangle. Let me see if I can put a 30 in here. Okay. So that's a 30, 60, 90 triangle right now. All right, well, this radius was 1, remember. So this hypotenuse actually goes from the origin all the way onto my circle. Therefore, it's the same as a radius. It has a radius of 1. Now apply those 30, 60, 90 rules. If the hypotenuse is 1, then the short side is half of that. And if the short side is 1/2, then the longer leg is 1/2 times the square root of 3. And when you multiply that straight across, you get √3/2. Okay? All right, so now you would probably remember those weird, that this point right here has those weird coordinates, square root of 3/2, comma 1/2. Well, where does that come from? Okay, well, if we just start at the origin and treat this like a normal coordinate plane, then we go over the square root of 3/2 and up 1/2 to get to that point. Over square root of 3/2 and up 1/2. Okay, well, in addition to that, there's also some right triangle trig going on. You may remember the rule for sine of an angle. Let's do the sine of 30 is opposite over hypotenuse. So the sine of 30, if I start at this 30-degree angle, it would be opposite, which is 1/2, over hypotenuse, which is 1. So the sine of 30 would be 1/2 over 1. And that is why this coordinate always represents your sine. The cosine of 30 would be adjacent over hypotenuse. Okay, well, starting at the 30-degree angle again, adjacent would be the square root of 3/2 over 1. So the cosine of 30 would be the square root of 3/2, and that is why this always ends up being your cosine. So that's kind of messy right now, but that is where those coordinates come from that are all around your unit circle. Okay? Now I'm going to erase that. Clean it up a little bit. So what we have so far is for a 30-degree angle, the cosine is √3/2 and the sine is 1/2. Remember, it's alphabetical. Cosine and then sine. Well, we can pretty much do that same exact process for the 60-degree angles. So now I'm going to draw a triangle at 60 degrees. Okay. The angle inside there is now 60 degrees. Okay, but this guy here is still a radius, so it's still a 1. The short side is 1/2, and the longer leg will be 1/2 times the square root of 3, which is √3/2. Now if I start at the origin and go over and up, it basically reverses those coordinates. Okay, and that's why the cosine and sine of 60 are the opposite order. Okay? Okay, so continuing that idea, we drew this 30-degree angle and dropped a triangle. Well, let's do the same thing down here. This would be a 30-degree angle also, down here. If this inside angle is 30 degrees, we're going to go over the square root of 3/2 and down 1/2. Over the square root of 3/2, over the square root of 3/2 and down the short side. Okay? And that's why that sign is negative. In quadrant 2, same thing. This is 30 degrees also. We're going to go over the square root of 3/2 and up 1/2. So this would be left the square root of 3/2 and up 1/2. And the last one, quadrant 3, if this is 30 degrees, then we're going to go over the square root of 3/2 and down 1/2. You just got to pay attention to the short side versus the long side. And the short side is across from the 30-degree angle. So we go left the square root of 3/2 and down 1/2. Okay, now remember, for all these coordinates, they actually represent, this is my cosine and this is my sine. So the cosine of 30 degrees is square root of 3/2. The cosine of negative 30 degrees is square root of 3/2. The cosine of, if this is 180, this would be 210 right here. The cosine of 210 is this guy. So the cosine is first and then the sine value. Okay? So all of my 30-degree angles, up 30, down 30, up 30, down 30. All of my 30-degree angles all have the same cosine and sine, and you just have to figure out which quadrant to know whether it's positive or negative, just like a coordinate plane. Yes, that's the bell because I'm at school. Okay, so now, similarly, the 60-degree angles. If I go up 60, we already discussed that that reverses your coordinates. Down 60, same thing. I'll fill in all my signs in a minute. It's a little quicker. Up 60 on the left side. And down 60. And then I'll fill in my signs, okay? In quadrant 2, I go left and then up, so it's negative and then positive. Quadrant 3, I go left and down, both negative. In quadrant 4, I go right and then down. Okay, so hopefully you can see this way and recognize that in all honesty, you should be able to figure out your unit circle values by just visualizing whether it's a 30-degree or a 60-degree angle, and really focus on just memorizing this guy, really, is all you got to know. Now, I'm sure you remember that there's a 45-degree increment in there also, but I usually just leave that out because usually most people who came from pre-calculus remember that the 45-degree angles are the easiest since they're all the same. But just in case you don't, the 45-degree angles would be in there, and those are all the ones that are square root of 2 over 2, both the sine and the cosine. So the cosine of 45 degrees is square root of 2 over 2, and the sine of 45 degrees is square root of 2 over 2. And in the other quadrants, just change the signs. All right, so where does that leave us? The next thing students struggle with is filling out that unit circle in radians instead of degrees. And I would like to right now take the time to explain what a radian is, but I don't want this video to be too long, so I'm going to do a side video that if you want to know what a radian is, it will tell you what it is, and it'll be short. Okay, so I'm going to go ahead and move on. All right, completing this in radians. Okay, if you know that we have 0, and most of you remember that one complete circle around the unit circle is 2 pi, okay? And that means halfway around the circle would be pi, okay? If you cut pi in half again, half of pi is pi over 2, okay? If we go by halves, this is pi 1/2, this is 1 whole, this would be 1½ right here. So that would be 3/2 pi. Those are the ones most people remember very easily. Okay, now the other ones, let's ignore the bottom half of my unit circle for right now. Let's just ignore this for right now, okay, and just deal with the first top half. Well, this goes from 0 to pi, and it does it in 6 equal pieces of pizza. 1, 2, 3, 4, 5, 6. Pretend that was nice and neat. So I'm cutting from 0 to pi in 6 equal pieces of pizza, so we're going to count by sixths. So this would be 1/6, 2/6, 3/6, 4/6, 5/6, and this would be 6/6. But it's 1/6 of pi, okay, which you know is pi over 6. 2/6 pi, simplify that, and you get pi over 3. 3/6 pi is pi over 2. 4/6 pi would be 2 pi over 3. 5/6 pi is 5 pi over 6. And 6/6 is just pi. Now the bottom, if we continue that, we're just counting by sixths, okay? So if this one was 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, then this is 7/6, 8/6, which would be 4 pi over 3, 9/6, which is 3 pi over 2, 10/6, 11/6, and then 12/6 is the same as 2 pi. So those are your radian values. If you just remember that for the 30-degree increments, you're counting by sixths. then you don't have to memorize it or remember a pattern. Just count with fractions, okay? 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6, 7, 6, 8, 6, 9, 6, 10, 6, 11, 6, 12, 6. Okay? And for the 45-degree angles, the 45-degree increments, well, I lost it. Give me just a second. For the 45-degree increments, those you just cut from 0 to pi. You're going to do that in 1, 2, 3, 4 equal pieces of pizza. So for those, you count by fourths. This would be 1/4, 2/4, 3/4, and 4/4. Keep going. This is 5/4, 6/4, 7/4, and 8/4 is the same as 2 pi. So for the 45-degree increments, just go, try to ignore those green dots, just look at the red parts. Count by fourths because it's 4 equal pieces of pizza, okay? So it's 1/4, 2/4, 3/4, 4/4, 5/4, 6/4, 7/4, 8/4. Okay, so when you put it all together, the end result we know is all of this junk, but I definitely don't want you to have to do this every single time you have a trig question, okay? Honestly, I think as long as you understand how the angles work, the 30 degrees here, the 30 degrees here is the same as 30 degrees here, same as 30 degrees here, and same as 30 degrees here. If you recognize that, then all you really need to memorize is this guy right here. The rest you should be able to visualize, and then count by sixths or fourths around your unit circle. Hope that helped. If it didn't, then I'm sorry, you're stuck memorizing it. You know the drill. So move on now to applying this unit circle to solving equations involving trig. Good luck.